Hey boys and girls, it's Mrs. Walker. Today we're going to talk about how we can solve problems that have more than one step in them. So up until now, we've been solving a problem that has really one step where it asks you for an answer to one part of the problem and you know most of the information. Well, in today's lesson, we're going to have to find two pieces of unknown information to be able to solve. So our learning goal for today says, I can solve two-step word problems with multiplication and division. So I know you guys are going to rock this. So let's jump in and get started. First, what we're going to work on is an application problem. It's just like a warm-up math problem for us, okay? But pay close attention because this application problem is going to help us solve the next part of our lesson, okay? So the first problem says, red, orange, and blue scarves are on sale for $4 each. Ah, sweet. We're going to get some scarves today at a bargain, by the way, for only $4. Sounds pretty awesome. $4 each. Nina buys two scarves of each color. How much money or how much does she spend altogether? So she has her three different color scarves. There's $4 each. And how much does she spend altogether? So try and draw maybe some sort of tape diagram to be able to help you solve this picture or solve this problem. Okay, so use that picture to help you. Go ahead and click pause, and I want you to try and solve this problem on your own. Okay, what's it going to look like? Because in my mind, I'm envisioning some red scarves together, some orange scarves together, and some blue scarves. So I'm kind of maybe thinking about that as a tape diagram. So one red, two red, right? And then I would have one orange, two orange, and then one blue, two blue. Okay, so go ahead and pause, try and solve this problem on your own, and then click play when you're ready to go over it together. All right, friends, I'm so excited. Let's talk about this problem. Who doesn't love a good scarf? And normally it's pretty hot in Florida, so anytime we can wear a scarf, I'm all over it. Okay, so this is how I solved this problem. Okay, I drew a quick tape diagram to show me each set of scarves. So here's one red, one orange, two orange, one blue, two blue. Okay, because that matches our problem, right? Because she bought two of each color. I don't know how much the total is going to be. That's why I have that question mark at the bottom. Dun, dun, dun. How much money am I going to need to buy all these beautiful scarves? But what I do know in this problem is that each scarf is $4. Okay? So to be able to solve this problem, I can do it with multiplication, right? Because there's 4 in each group, and there are 1, 2, 3, 4, 5, 6 groups. So I could solve this with 6 times 4, okay? Or I could skip count by 4s 6 times. So I could go 4, 8, 12, 16, 20, 24. Ooh, I did pretty good on that one. Okay, so here is, let me shift this over a little bit so we got some more space. So here's kind of how I broke down my math. So what we just talked about right here was the 6 times 4 equals 24. She spends a total of $24. What I want you to notice too, just up here, I just have 2 plus 2 plus 2 equals 6 scarves. So I just wanted to remember that there was a total of 6 scarves in this problem. Okay, so before we move on to the next part, I would like for you to draw on your dry erase board that tape diagram real quick. Okay, so draw that tape diagram. If you need time, click pause. Okay, when you're ready, click play, and then we're going to talk about this same problem, but in a different way. Okay, I'm going to leave you on a cliffhanger there for just a second while you wait to see. Okay, so draw this one. When you're ready, click play, and we'll move on to the next part of our problem. Okay, I'm going into the next one. Here we go, friends. Okay, so this next part of the paper, or this part of the problem, or we're going to use the information that we used in the last problem, but we're going to draw a new tape diagram and new pictures to be able to help us solve this problem. So now what I want you to do, I want you to take your paper, and I want you to flip it over, and we're going to solve on the other side for this problem, okay? But then I want to be able to flip it back over if we want to look at what we did in the last tape diagram, okay? So here's our new problem. You can follow along on the screen with me as I read it. It says, red, orange, and blue scarves are on sale for $4 each. Nina buys two scarves of each color. She also buys a hat that costs $4. How much does she spend altogether? So remember, altogether, I want to know about scarves and hats, right? So this first thing I want to talk about is how is this problem similar to the application problem that we just solved? So if you flip back over, maybe you're bored, how is that one similar to what we're talking about with this problem? So for the most part, the question's pretty much the same, right? But the new problem adds the cost of the hat to the total. So we have to be thinking about that. So we have to be mindful of there's two parts to this problem. We have to find out how much she spent on all those scarves, and then we have to be able to add the cost of the hat to that total. So that's why this is a two-part problem, okay? So how can we use the answer from our application problem to help us solve the new problem? So if you want to look back at your tape diagram, flip that paper over again. And how can we use how we solved that problem to help us in this new problem? Okay, so what I want to do is I want to pull out here for you. Oops, let me grab my pen here. Let's take a look at this. Okay, so this is our tape diagram from before. I just brought it back so you guys could see it. It's also on the back of your paper. But what I wanted to notice is that each one of these boxes is one unit. Okay, so this is one unit, which is one scarf. Okay, the value of each unit or the value of each scarf is that $4. Okay. But what do the 6 units represent? So 1, 2, 3, 4, 5, 6. What does that represent? Yeah, it represents the 6 scarves that we have total, right? So remember that's how we went back and totaled the 2 plus 2 plus 2 of each color to make sure we had 6 scarves, okay? So I labeled that originally with a question mark, but now we really know that that is 24, okay? Because we came up with that before, because we did 6 times 4 equals 24, okay? So I don't really have an unknown of the total of scarves anymore. I know that it's $24, okay? Now, here's where it gets a little bit different, okay? So I have to add, let me grab this here. I have to add to this tape diagram. I'm just going to put this on top because I'm adding more to it. I had my scarves and I'm adding a hat, the cost of a hat to it, okay? So now the total cost of the hat, of the scarves, is still 24, but I added that cost of the hat, which is $4. So I have 4 plus 24. So my 4 comes from the cost of my hat, and the 24 comes from the total of the cost of the scarves. So what's 4 plus 24? What can you guys come up with? Or you could do 24 plus 4 to make it easier for yourself. Yeah, it's 28. So 4 plus 24 is 28. Don't forget to put your dollar sign in there too, so you're labeling so you know it's not just the number 28, it's $28. Okay? So if we look at this, I really have 6 units down here, right? 1, 2, 3, 4, 5, 6, and they're all $4. Well, if I look up here, I have like another unit, right? And this is $4. So how many units did we really add together to find the total of both of these items? We did 1 unit plus 6 units. So we did a total of 7 units. Okay, so now what I want you to do is I want you to write a multiplication sentence that goes along that we could use to find the total number of scarves and a hat without finding the value of those scarves first. Because we know that they're worth the same value. So how many units can we come up with? Try and write a multiplication sentence that you think might go along with that. And then click play when you're ready to talk about it. Okay, friends, here's what I came up with. 7 units of 4 gives me that $28. So I did 7 times 4 equals 28. Okay? Hope you guys got that same thing. I'm sure you did. If not, don't worry, because we're going to do more practice with this type of problems too. Okay? So let's jump into the next problem that we have. It says, sorry, let me grab it for us here. It says, Mr. Lim buys 7 plants for his garden. Oh, he's going to make his garden so beautiful with all those plants. Each plant cost $5. The next day, he buys a rose bush that also costs $5. How much more do the 7 plants cost than the rose bush? So, what is the information that I know from reading this part of the problem? Well, the first thing I know is that each plant, let's get this here, each plant costs $5. Oh, I'm going to change my color on that one. Each plant costs $5. Ta-da, there we go. Okay. I also know that a rose bush costs $5. So no matter whether they're buying a plant or a rose bush, $5. That's how much they cost. Okay. What's the unknown information in this problem? Yeah, well, if you said, well, we can't answer the question of how much more do the 7 plants cost than the rose bush, right? So that's one unknown. And another thing is we don't know how much those 7 plants cost. We don't know the total yet. So because we don't know 2 pieces of information, that tells me that this is going to be a 2-step problem, okay? So notice that there's 2 unknowns in our problem. Let me show you part of this here. Oops, bring it over. Ta-da! Okay, so here are 2 parts of our problem that we don't know yet. Okay, or sorry, this is the first part. So the first one is modeling the unknown of the cost of the 7 plants. So what I did was, I don't know how much all of these plants cost, but I do know that there's 7 of them. So there's 7 groups or 7 plants. That's where that first factor comes in. And the second one I know is there's $5 for each one. So I can solve 7 times 5 to be able to solve this problem. So for this one, oh, I love that there's a 5 in it, friends. Why do I love that there's a 5 in this problem? Well, if you said because I can skip count by 5s, you're right on. Because I love skip counting by 5s. It's so much easier than skip counting by just about anything else. So let's skip count by 5s 7 times together. So we're going to count until we get 7 fingers up. Okay, so here we go. Ready? 5, 10, 15, 20, 25, 30, 35. Okay, so 7 times 5 is going to give me 35. Okay, so it's $35, right? We need some money for this. That's how much the plants cost. We can't just pay in 35 numbers. We have to pay in dollars for this one, okay? So we could figure out the cost of that by multiplying 7 times 5, okay? So have we answered the total problem up here of how much more do the 7 plants cost than the rose bush? No, not yet, okay? We've only solved how much those 7 plants cost. So now we need to do a second step in this problem. That's why it's a 2-part problem, okay? Or a 2-step problem. So the first step, we just solved it, okay? We had to find out how much those plants were. So now what I want to look at is all I did for this is, remember, I took my exact same tape diagram, but I brought over this rose bush, okay? Those rose bushes worth 5, so I lined it up nice and neat and straight with that other part of the problem as well, okay? So I have my plants and my rose bush. Now, how do we find out? What strategy could we use to answer that question of how much more do the plants cost than the rose bush? So we know that there's a total, let me bring this in here, of $35 for just the plants, okay? So I know that I could solve this one of 2 ways. The first way that I could solve it, let me bring this guy in here, ta-da, is I could count 6 units of 5. So basically what I could do with this, friends, is because I have a 5 here and a 5 here, I could pretty much cross those out because they kind of cancel each other out. And then I could just skip count by 5s for the rest of it. So I could go 5, 10, 15, 20, 25, 30. So I could use some multiplication to be able to solve that. 6 units of 5 is also 6 times 5, okay? I could also solve this problem with a little bit of subtraction, okay? Because I know the total is 35, and I know a rose bush only costs 5, so I would just subtract those from each other, okay? So there's 2 different ways that I could be able to solve this problem, okay? Now, if I say now we have, let me grab my pen here, 6 units of 5, we skip counted that and it gave me 5, or you could use subtraction, 35 minus 5 still gives you 30. Oh, remember, label, 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 so we know what that is. So it's $30. How have we answered the question now that we have 30 as our answer? What do you guys think? Remember, it says, how much more do the 7 plants cost than the rose bush? Did we figure that out and solve that correctly? Yeah, we sure did. Okay. So make sure that when you're reading each question, you're saying what's the information that I know and what's the information that's unknown in this problem for me to be able to solve. And sometimes you might have to solve the problem 2 times or in 2 steps to be able to solve the total problem. Okay. Let's jump in and take a look at another example. Okay. So, oh my goodness, this is about almonds. Do you guys like almonds? Let's see. They remind me of Almond Joys. Remember the little candy with the coconut and the little almonds in them? Because they're like mounds, but they don't, but they have nuts in them. Almonds. Okay, sorry. You know, I get a little distracted. I love my candy. So any connection I can make to candy. Okay. Focus, Mrs. Walker. Okay, so let's take a look at our problem. It says 10 children equally share 40 almonds. How many almonds will 3 children get? Okay, so let's break this problem down a little bit. Remember, you want to ask yourself what's known and what's unknown. You have to start with that first to see if you need to have more than one step to solve the problem. So the first question I'm going to ask is, what information is known in this problem? So what do I already know in this problem? Okay, I know the total amount of almonds and the number of children. So I know that there's 10 children and I know the total amount of almonds is 40. Okay, what's unknown in this problem? Yeah, I don't know how many almonds that 3 children get. Okay, so in order to solve this problem, what do I have to do first? Well, I want to know how many 3 children get, but first I need to figure out how many one child gets. And the way that I think would be the best strategy to do this would be to use that fair share strategy. So if I were to come over here and I were to say, okay, I have my 10 children, I don't know how many each child is going to get. So you'll have to use that fair strategy. So down here, I have 40 almonds in this pile right here. They're all stacked on top of each other, all nice and neat. So what I would have to do is the fair share strategy and go one person gets an almond. So 1, then I have to go 2, the next person. I don't want to fill up one whole box first because I don't know if that's going to be correct. So I want to be able to, remember, fair share. Everybody gets their fair share in the same number. Okay, that's why it's called the fair share. Okay, so 1, 2, 3, 4, 5, 6, oh goodness, 7, 8, 9, 10. Okay, so, and did I get to 40 yet? No. So keep going and going one in each for each child until you get to 40. Okay, so go ahead and pause the video and I want you to share on your tape diagram. Okay, so go ahead and draw that tape diagram. 10 children, so 10 boxes, and each child is going to get a certain amount. Do we know the amount? Not yet. That's where you got to use that fair share strategy to split up those 40. Okay, so just like I did, I'm at 10, so I would keep going. 11, 12, and so on until all 40 of my almonds are used up. So go ahead and draw that in your tape diagram. Click play when you're ready to share what your tape diagram looks like, and then what my tape diagram looks like is what I'll share with you as well. Okay. All right, friends. So here's what my tape diagram looks like. I just went through and kept counting all the way until I got to 40, and I realized that one child, which is one box, that's one unit, is one child, gets 4 almonds. Okay, so have I solved this problem? Some say yes and some say no. Well, let's take a look at the question. It says, how many almonds will 3 children get? So if I just say 4, is that how many all 3 of these children get right here? Because I just labeled 3. 1, 2, 3. Let me do that in the color. Ready? 1, 2, 3. That's where this funny line right here comes from. That's 3 of the children. So if I just say 4, I'm not there yet, friends. I got to keep going, okay? That was just solving the first step in our problem. Now we need to be able to figure out how many almonds are for each of the students or the children, okay? So I could solve this with repeated addition of 4. Okay, let me change. So I could do 4 here, another 4, and another 4, and that's where they get 4 plus 4 plus 4 from, okay? I could count those. Let's count them. Or let's skip count, right? Let's do that, okay? Or let's count. It's fine. 4, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I could come up with 12. Another way that you could solve this problem would be you could use your multiplication, okay? And that's where you could really skip count by those 4. So you could go 4, 8, 12 to be able to come up with that same answer. So 12 and 12, no matter how you do it. Now, did this 12 solve our problem and tell me how many almonds that 3 children are going to get? Yeah, it sure does. So the first part of our problem was we had to find out how many one child's got of those 40 almonds. And once we knew that, then we had to multiply that by 3 to be able to find out how many 3 children got. Okay, so bravo with that, my friends. You guys did a really good job with today's lesson. Please head back on over to the module to see what you need to complete for independent practice today. As always, if you have any questions or need any help with anything, please don't hesitate to reach out to me. I would love to help you in any way that I can. I hope you guys have a great rest of your day, and I will see you all soon. Bye, friends.